Hi guys, welcome to Technowizard. Myself Vinita Pandey and I'll be dealing with the JV Gupta book. Basically, I'll be providing you the solution of JV Gupta question. So I'll begin with the network subject because it's a very basic subject. So yeah, let's have a look at the first question of JV Gupta book. Right. So okay, first question is an electric current is the first option is okay. So first option is an electric current is the random movement of electrons in a conductor. So this option is wrong. Why? Because it is saying as random movement. So if there is random movement of electrons, so it will collide with the other electrons and with the collision of with the conductor surface. So basically it will generate heat. So this option is wrong. So next option is movement of free electrons predominantly in one direction, though this option is right. An electric current is basically the movement of free electron predominantly in one direction. So if electrons will move in one direction, so the current will flow in opposite direction to the flow of electrons. So it's basically a convention, right? Next option is pressure difference between the two poles. So if you want to flow the current, then potential difference is must. If the potential difference between any two ends, for example I'm considering this resistance, if the potential difference between these two ends is zero, then there will be no current. For example, if I'm considering 3 volt potential at this node and 3 volt potential is also there at this node, then the current flowing through this is zero because there is no potential difference. So and next option is the power that causes the drift of electrons. So this option is also wrong because definition of electric current is this only. So for this question option B is right. Next question is okay, copper has a resistivity of 17 into 10 to the power minus 9 ohm meter. So they have given us rho, which is 17 into 10 to the power minus 9 ohm meter. What is the end-to-end resistance of a copper strip? So we have to find out resistance. 2 centimeter long, so they have given us length also, which is 2 centimeters. So we'll convert into meter, that is 2 into 10 to the power minus 2 meter, with the cross-sectional dimension. So they have also given us area, cross-sectional area I'm talking about, that is 5 mm into 1 mm. So we'll convert this also in meter, that is 5 into 1 into 10 to the power minus 6 in meter. So we all know the basic formula of a resistance is R is equal to rho L by A. So they have given us all the entities, so we'll the value simply. So 10 into minus 17 into 10 to the power minus 9 into length is 2 into 10 to the power minus 2 divided by resistance, sorry, cross sectional area, that is 5 into 10 to the power minus 6. So after calculation we'll get 34 by 5 into 10 to the power minus 11 plus 6 is minus 5. So after dividing this we'll get 6.8 into 10 to the power minus 5. We need the answer in microcoulomb, so this will be 68 micro ohm. So option B is correct, right? So next question. Okay, next question is for a fixed supply voltage. For a fixed supply voltage, okay, let me select pen. Okay, yeah, for a fixed supply voltage, the current flowing through a conductor will increase when? Okay, so basic formula according to the Ohm's law is V is equal to I into R. We have to relate current with the voltage and resistance, so according to the Ohm's law, right? So it is saying that for a fixed supply voltage, it means voltage is constant, right? So it means current is inversely proportional to resistance. So it is saying that the current flowing through a conductor will increase. Okay, so we have to increase the current, for that resistance has to decrease, and the formula for the resistance is also R is equal to rho by L. So we have to decrease the resistance, for that length of the conductor has to decrease and the cross section area has to increase. So right, so let's have a look at the option now. Area of cross section is reduced. Okay, if we reduce the cross-sectional area, then resistance will increase. So this option is wrong because we want to increase the cross-sectional area in order to obtain less value of resistance. Length is reduced. Okay, so this option is right because we have to decrease the length. Length is increased, wrong. Length is increased, and this option is also wrong. So for this question, option B is correct. Okay, next question is, a battery is connected to a resistance causing a current of 0.5 ampere. Okay, 0.5 ampere. Okay, let me draw the circuit. A battery is connected to a resistance, I'm denoting it with the R and the battery with V, causing a current of 0.5 ampere. So we'll apply the KVL. V is equal to I into R, that is equal to voltage is equal to 0.5 into resistance. So this is equation 1. Next it is saying that the current drops to 0.4 ampere when an additional resistance of 5 ohm is connected in series. Okay, so this is our battery, this is already resistance R is there. Now we have connected an extra resistance of 5 ohm, right? Same voltage is there, and now the current is reduced to 0.4 ampere, right? Now the KVL equation will become current into R plus 5. So voltage is equal to 0.4 ampere current is there, resistance plus 5 ohm resistance is there. So I'll denote this equation with equation 2. Now we will solve these two equations and find out the value of V and R. Okay, equating equation 1 and 2, equation 1 with equation 2 will get 0.5 R is equal to 0.4 R plus 5. So this will be 0.1 of R is equal to 5. So sorry, this will be 5 into 0.4, which will be simply 2 ohm. Okay, so this will be 2. So we'll obtain the value of resistance as 2 divided by 0.1, that will be equal to 20 ohm, right? Now we'll also find the value of voltage. V is equal to 0.5 into R from the equation 1. So 0.5 into 20, so this will be 10 volt, right? So we have calculated the value of source and the resistance. Now it is saying that the current will drop to 0.2 ampere when the resistance is further increased by. Okay, so it is saying that we have already calculated the value of resistance as 20 ohm, voltage is 10 volt, and already 5 ohm resistance is there. So we have to add some extra resistance, I'm denoting it with R1. So we have to find out the value of R1 so that the current will drop to 0.2 ampere. So by simply applying the KVL equation, we'll obtain the value of R1, and that will be the answer. So equation will become V is equal to current into 20 plus 5 ohm, that is 25, plus R1. So voltage is 10 is equal to, now the current value will become 0.2 into 25 plus R1. So this will be simply 10 divided by 0.2 into 10, that is, so R1 value we are obtaining is 25 ohm. So yeah, for this question 25 ohm is the right answer. So let's see next question. A 12 volt automobile light is rated at 30 watt. The total charge that flows through the filament in 1 minute. Okay, so they have given us power, which is 30 watt, and they have also given us voltage, which is 12 volt. So we simply know power is equal to voltage into current. From there we calculate the value of current, that is power by voltage. So power they have given is 30 divided by 12, which will be 10 by 4, that is simply 2.5 ampere of current. Now they are asking total charge. So we know that current is equal to charge flowing per unit time. So we know that current is 2.5 ampere. We need to find out the charge in time. The standard unit or the SI unit of time is in seconds, so we need to convert 1 minute into seconds, right? So 1 minute will be in second. 1 minute is equal to 60 seconds. So from here we'll calculate 25 into 60, right? So this will be simply 25 into 6 is what, 180. No, it's 150 coulomb, right? So option C is correct for this question. Okay, so let's see next question. Next question, it is saying that three parallel resistive branches are connected across a DC supply. What will be the ratio of the branch current I1 is to I2 is to I3 if the branch resistance are in the ratio R1 is to R2 is to R3 is 2 is to 4 is to 6. So simply we'll draw the circuit. Okay, we are considering three resistive branches and they are connected across a DC supply. For example, we have applied V volt. So we all know that in the parallel voltage is same. So V is equal to I into R. So current is equal to V by R. In the parallel circuit, voltage is constant. So current will be inversely proportional to the resistance. It means if the value of resistance will increase, so current flowing through that resistance will decrease. So see this, R3 resistance value is 6. It means this is the maximum resistance. So current flowing through 6 ohm resistance will be the minimum. So see the option. It means maximum current will be flowing through R1 and minimum current will be flowing through R3 resistance, because R3 resistance value is maximum because it is 6 times and R1 resistance is something 2 times. So it maximum current will be flowing through R1 and minimum current flowing through R3. See the option. This is 326 wrong because in this maximum current is through R3 resistance, so this is wrong. This is also wrong. This is right because from R1 resistance maximum current of 6 is flowing and R3 2 is ohm flowing. So this option is correct. And in this option minimum current will be through R3 and in this minimum current is flowing through R2. So this option C is correct. Okay. Next question. For the circuit shown below, the equivalent resistance will be, okay, so we have to find out the equivalent resistance. So let's first mark the terminal. Okay, I'm denoting this terminal as A and this terminal with B, right? So the points or will change if there is a drop. For example, this is A point, so there is no resistance, so this is A point only, right? So this whole point will be considered as A because there is no drop. Similarly, this point will be considered as B. Similarly, these points will also be considered as B point. It means in between A and B 12 ohm is connected. Similarly here in between A and B 12 ohm is connected, and in between here same 12 ohm is connected. It means between the points A and B three 12 ohm resistance are connected after rearranging this circuit, right? So this is 12 ohm 12 ohm, and we know that the formula of R equivalent in case of parallel network is R by N if equal value of resistance are connected in parallel. So here the value of R is 12 and three resistance are connected in parallel, like three branches are there. So the overall R equivalent will be 4 ohm. So for this question option C is correct, right? Next is 12 1 ohm resistances are used as edge to form a cube. Okay, the resistance between the two diagonally opposite corners of the cube is, okay, so let's first draw a cube to understand this. Okay, so basically this is a cube I'm drawing. They are saying 12 1 ohm resistance are used as edges. It means this edge, the value of this edge is 1 ohm, right? So this is one corner A, this is another corner B. I'm applying, for example, I'm applying a voltage source V, right, between these two diagonally opposite corner. So as a result of this voltage source, a current will I will flow. So at this node A, there are three paths available, right? So current will divide equally, that is I by 3 will current will flow because three paths are available and value of each path will be equal, so current will equally divide. Now this I by 3 current is now having two paths, so now it will divide into I by 6 and I by 6. So from here I by 3 current is coming, and this I by 3 current will again split into I by 6 and I by 6. Alright, so now this current what will be, from here I by 6 coming, 6 by current is coming, and from here also I by 6, so both will add up and will result into I by 3. From same here you can understand, right? Now we will apply the KVL. I'm choosing different color pen so that you can understand, right? So now I'll applying the KVL in this loop. In outer loop I'm applying the KVL, right? So in this loop I'm applying the KVL. So I'll start with the voltage source minus V plus, now this branch current is I by 3 and resistance is R. They have already given, I'm assuming R, the value of R is 1 ohm, I'll put it later on. Next is plus this branch resistance is 1 ohm and current through this is I by 6, so I by 6 into R plus, here it is I by 3 current into R is equal to 0. So voltage is equal to current, I've taken common, into 1 by 3 plus 1 by 6 plus 1 by 3. So V by I is basically R of AB, that is we have to calculate R equivalent between the two diagonally opposite points, right? So after taking the LCM it will be 2 plus 1 plus 2, right? It means 5 by 6. So the resistance between the two diagonally opposite corners of the cube A and B will be 5 by 6, so option A is correct. Similarly, if they'll ask about inductance between AB, that will also be the same, that is 5 by 6 of L. Here L is, if L is 1, the answer will be 5 by 6 only, right? So now let's see next question. Okay, next question is, and resistors, each of resistance R when connected in series offer an equivalent resistance of 50 ohm. Okay, so suppose we are having the two resistors, they are connected in series, they are having, each is having a value of R. So what will be R equivalent? R equivalent will be 2R. Similarly, if there are n resistance and they are connected in series, so their equivalent resistance will be n into R. N is the number of resistors that are connected in series and R is a resistance value of each resistor, and it is given as, it is R equivalent is coming as 50 ohm. So I have equated it, equation 1. Next is saying this, and when reconnected in parallel the effective resistance is 2 ohm. It means when the same n resistors are connected in parallel, the equivalent resistance is 2 ohm. It means R by n is equal to 2 ohm. I have already told you the formula. If n resistors are connected in parallel, then R equivalent formula will be R by n. So from here R is equal to 2n. Solving these two equations, so after solving these two, so now solving these two equation, putting the value of R is equal to 2n, equation 1 will get n into 2n is equal to 50. So 2n square is equal to 50, n square is equal to 25. So n is the number of resistor, that is 5, it can't be negative, right? So we have obtained n is equal to 5, so put in equation 2, that is equal to 10 ohm. So the value of R is 10 ohm. So option D is correct. Okay, let's see next question. A current of 2 ampere is passing through a cell of EMF 1.5 volts. Right. Okay, having internal, okay, let me read the question again. A current of 2 ampere passes through a cell of EMF 1.5 volt having internal resistance of 0.15 ohm. The potential difference across the terminals of the cell. Okay, so there is an internal resistance whose value is 0.15 ohm and a EMF of 1.5 volt. So current of 2 ampere is flowing. So we need to find out the potential difference across the terminal. So this will terminal will be positive, this will be negative. We have to find out the V. So we'll simply apply the KVL in this loop, right? So minus V. So plus V. I'll start with here. Plus V minus 1.5 plus 2 into 0.15 is equal to 0. So V minus 1.5 plus this into 100, so this will be 3 by 20, that is 0.3 is equal to 0. So voltage will be is equal to 1.5 minus का 0.3, that will be equal to 1.2 volt, right? So option D is correct. So let's look have a next question. Okay, next question it is saying that in a parallel resistive circuit, opening a branch results in, okay, for example, I'm having a 3 branch, and if one branch is opened, like for example this is removed, then this will result in the increase in the total resistance, decrease in the total power, no change in the total voltage and the branch voltage. This option is right. Why? Because 3 branches are connected in parallel. If one branch is removed also, then the voltage across these or the branch voltage will remain the same. So this option is right. And the current flowing through this is I. If this resistance is removed, then the current will decrease. So total power, which is equal to voltage into current. So voltage is constant because the circuit is connected in parallel. So value of current will decrease because one resistance has removed. So its current will be eliminated. So overall current will decrease, right? So overall power will decrease. So this option is also correct, and it will increase in the total resistance. So this option is also right. So all options are correct, so this is option D, right? Next question is, how are 500 ohm how are 500 ohm resistors connected so as to give an effective resistance of 750 ohm? Okay, so first option is 3 resistors of 500 ohm each are in parallel. Okay, so if all the resistances are in the parallel, then R equivalent will be equal to R by N. So each resistance value is 500 ohm and 3 branches are there, so that will not be equal to 750, right? So this option is wrong. 3 resistance of 500 ohm each in series. Okay, if they are connected in series, then what will be R equivalent? 500 plus 500 plus 500, that will be equal to 1500. This option is also wrong. Now 2 resistance of 500 ohm each in parallel, so R equivalent will be 500 by 2, that is 250 ohm. So this option is wrong, so this will be automatically correct. 2 resistors of 500 ohm each, 2 resistors of 500 ohm each in parallel. Okay, I'll show you. They both are connected in parallel and the combination in series with another 500 ohm. So this their combination is in series with 500 ohm. So If the two 500 ohm resistance are parallel, so their R equivalent will be what? 500 by 2, that is 250, and 250 plus 500 will be 750. So option D is correct. Next question is, three resistances each of R ohm are connected to form a triangle. Okay, so I am showing this. There are three resistances and they are forming a triangle. Their value is R. Okay, now the resistance between any two terminals will be, okay, I'm considering this terminal as terminal A and this terminal as terminal B, so we have to find out R of AB. So from here we can see that they both resistance are in series. It means R in parallel with 2R. Simple. So after solving these, R into 2R divided by 3R, so this will be simply 2R by 3. Option D is correct. So next question, in the given figure the value of resistance R in ohm. Okay, so this is a figure and we need to find out the value of R. So we'll simply apply the nodal. For example, in this loop current flowing is I1, and in this branch current flowing is I2, and in this branch already current is given 2 ampere. So we'll apply the nodal at node A. Okay, nodal at A. So basically we always consider the current in outward direction from a node. This is a basic standard formula or the method to solve any network, right, using a nodal method. So what will be the value of I1 current? I1 will be voltage at A minus 100 divided by 10. This is I1 current value, plus I2 current is V of A divided by 10, and already current through this branch is given, so we'll simply put 2 is equal to 0. So after solving these, V of A, that is 2VA minus का 100, 2VA minus 100 plus 20 is equal to 0. This is 2VA is equal to 80. So we have find out the value of VA, that is 40 volt. Now the current through this will be, current is equal to V by R. So we already know the value of current is 2 ampere and voltage we have calculated, which is 40 volt. So what will be the value of R? So R will be simply 20 ohm. So I think this was 20 ohm, it got misprinted, so option B is correct. Okay, so yeah, for this question resistance we are getting value as 20 ohm. Okay, so that's it guys for today's session. I hope you liked my session, and if you do, keep watching my session. That's so yeah, see you in the next lecture. Till then,